So it's a kind of review. Those are the three normal forms. So in the first, the table must have a key and all shall be dependent on that key. The second normal form is the first normal form, and the table must have a key and all shall be dependent on the whole key. And the third normal form, the table must have a key and all shall be dependent on the whole key and nothing but the whole key. Okay. So remember those three rules. We need our tables to have that consistency. Now, again, if we follow the procedure that we followed to design or to get to the relational model, like the one you guys are going to be following for your application projects, when you get to your tables and verify these three rules, you're probably going to, your tables are going to be in normal form. You're not going to have a problem with this. But we're going to see situations where we're going to be doing some a bit of sort of reverse engineering, where we're not going to necessarily follow the process that we followed. We're going to have certain information, a report, an invoice, or something, where from that information we're going to extract the tables. And there's a process to do that. And when we do that, we need to verify the normalization. And those are the examples that we're going to start seeing today. So I've got three examples that I want to go through. And then I want you guys to work on some examples, and we're going to review them. That's going to kind of round out the topic. We're going to do that today and Monday. And on Wednesday, we're going to start off with a simple access intro or tutorial or primer. Let's look at these situations. These situations are a bit different than the ones we have been looking at up to this point. That's a table that has student information. You see that, right? That's student information. Remember when we were talking about the situation of a university, and I asked you what are the typical entities that could be in a university scenario? Well, students are an entity. What's another entity that can be? Courses, professors, etc. And we define them separately. And then we relate them and we get the relational model, right? And that's usually, normally, typically going to give me a table for students, a table for professors, a table for courses, and then there's going to be a relationship, probably a many-to-many relationship that's going to give me another table. And that gives me the tables, okay? That's the process that we follow. But now imagine it's the other way around. This is what we're given. Let's say that it's a very small school that keeps all of its information in an Excel spreadsheet. And this is the information that we have. And we want to structure this into a relational model with the correct definition of tables for our database. Can somebody identify problems that we have with that table? Daniel?
One is that, of course, it's on each student. We have many, and
Exactly.
I don't know if it's like we can see the grades, and we can see that they have if they have two courses, they have 3 grades, but we don't know if those grades are in the same order.
Exactly. The good observation. The courses column and the grade points column are don't have atomic values, and that can be confusing because, as you mentioned, I mean, we've got 3 courses here, and then we've got 2, 3, 3. We can assume that the 2 is for the first one, the 3 is for the second one, and the 3 is for the third one, but that might not be the case. So the organization of the data as it is confusing. And it's not in the first normal form just because of the fact that we don't have atomic values. Okay. So what we want to do is grab this information, this table or this data, and the process that we're going to follow is a process of unpacking. Okay. What does unpacking mean? We're going to receive all of our data information in one package, which is usually going to be one table, one invoice, the ledger that we talked about, or something like that. And from that, we're going to unpack and create the different tables and relationships that represent that and that are congruent with the normal forms. So we're going to do that with this one. And there's a few questions that are being asked there. is the table in first normal form? Yes, no, why not? If it's not in first normal form, then redesign the table so it is. Is the resulting table in second normal form? If not, redesign it and it's in third normal form. And if not, then redesign it. Okay, so let's sorry, let's follow the unpacking process. By the way, the examples that I'm showing here in that are in the PowerPoint, they go step by step. So when you're doing one of your exercises, you can kind of follow those steps, and you're going to get to the results, and they're all shown there. So the first thing we're going to do is to kind of analyze the table, and this is what Daniel identified right here. These aren't atomic values. That can be really confusing. And again, you might say, wait a minute, a school doesn't keep its information like this. Well, we don't know. Again, it might be a very small school that doesn't have a large database. It's literally somewhere where information is kept that way. So these are atomic values. Okay, we need to. So that is why the table is not in normal form. So the first thing we're going to do is we're going to unpack those values, and we're going to redesign the table doing the corresponding relationships that Daniel mentioned that we couldn't identify in the original table. So now what we're going to do is that we're going to distribute the information, and we are going to separate the courses, one into each row and one and the breakpoints as well. Is this table in the first normal form? Yes, it is, because it complies with the 4 rules. Well, first off, we have a primary key. In these examples, the primary key is going to be underscored in bold. So alpha, I don't know why they're calling it alpha in this example, but alpha is the student ID. So that is the primary key. Each of the columns has a name. The values are atomic. The order doesn't matter. And the type of data is the same. So it is in first normal form. But still, even if it's in first normal form, what's the problem with the data as I have it, as it is right there?
There's a lot of repeated values.
It's we unpacked it. We generated more records, and there's duplication and a bit of redundancy that can be confusing. So we've got John Doe 3 times with 3 courses, 3 grade points, and their email is repeated. So this might not be the best way to keep this information, because if John Doe is taking 10 courses, then the record of John Doe is going to be repeated 10 times. Okay? And we might not want that. So this is our first step. Just verify the first normal form. Now let's continue the unpacking process. Is it in second normal form? No, it's not, because there are partial dependencies. For example, the grade is going to depend on the course, and obviously the student, but it's going to depend on the course. So these are partial dependencies. And the partial dependencies are going to generate that repeating of data or redundancy. We want to try to eliminate that. So what we're going to do is that we're going to create a composite key. And that's actually the way it happens with regards to how information is organized for students and courses, and et cetera. A student, your grade. So for example, Daniel, your grade for this course is associated to your student ID and the course ID specifically. We need both of those things to identify the grade for your course. There's another value that we add here, which is the group. Here, we're probably assuming that the courses don't have many groups. But we need both of those things. So if I just have your student ID, I don't know, and I want the grade for you're taking calculus right now, right? If I want the grade for calculus, I can't do that. If I have the code for calculus, and I want your grade, I can't get your specific grade. I need both of them. So we create a composite key, which is alpha, or the student ID in the courses. Now, we can have, or we can find the specific data that relates to the student in a specific course. But still, the information is redundant and repeated. And we still have dependencies. We still have some things that just depend on, we have some things that just depend on alpha, which is the name and the email. And we have other things that depend on the courses, which are the grade points. And those dependencies, we want everything to depend on the primary key. So what we're going to do is that we are going to separate, and we're continuing this unpacking process. We're going to separate the original table into two tables. One is a students table, and that kind of was obvious that we need a students table. Students is an entity, okay? So we have a students table that has the student ID, the name, the email, and the courses that he or she is taking. And then we're going to have another table that has courses and alpha as a primary key and the grades, and those are going to be separate. Both of these are in first and second normal forms because in the first table, we don't have partial dependencies. All of the fields are going to depend on the primary key. And in this other table, all of the fields are going to depend on the composite primary key. So the partial dependencies have been eliminated. That means that they're in first and second normal forms. In this particular case, the tables are in third normal form because there aren't any transitive dependencies, meaning that the fields, the columns, there isn't an attribute or a column that depends on another attribute that isn't the primary key. In that case, they're in third normal form. There's no verification necessary. The resulting tables that are normalized are those that we have there. Okay. We could add things to this structure. If we wanted to add a professor's table, we could add it and relate it as well. But for this example, for the information that we were given, these two tables comply with the normalization. Okay. So what were the steps we followed, just to kind of review? The first step is that from the original information, we unpack the data so there's no atomic values, and then we get a new table. That's in first normal form. Next, we try to identify the partial dependencies and eliminate them by either creating a new table or creating a composite key that eliminates them. So we do this. And lastly, to try to eliminate the partial dependencies, if necessary, we separate the tables and validate that the partial dependencies don't occur. And lastly, we just verify that there are no transitive dependencies between the attributes. And if all of those things have been verified, then the tables are what we call normalized. Okay. In your final project, in your next deliverable, one of your next deliverables, you're going to have to present the relational model and the normalized tables. The normalization is just for you to verify that the three normal forms for each of your tables, that the three normal forms are valid. And again, if you, yes.
Is this fun? Is that going to the grocery store?
It is. I find this topic, this is, I took this course when I was studying my master's degree. And I don't know, the normalization topic, I think because when I took the normalization topic, we saw all of the normalization forms, and it's really a headache.
Is they coming back from the groceries? Like, you have your bags,
And you put the fruits here, you put the.
and you unpack them, and you put them in the fridge.
Yeah, let's get the, and you just verify that you're not putting the fruits in the freezer and the stuff you need to put in the freezer somewhere else. Yeah, that's a good analogy. But still, I'm glad somebody's finding it a little bit fun. Let's look at another one. By the way, remember that we're kind of doing like reverse engineering. Imagine that what you get is this. This is a report. This would be the result of what a database would give us. Let's say that you guys are the developers of the database. And the pet store is saying, you know what, in a database, I want a report like this. So instead of doing the analysis like we've done it, where you talk to the person and say, you know what do you do in the pet store? What services you have, et cetera, and you identify the entities and you do that. The pet store is saying, this is the report I want. Like, for example, what team has the hairdressing? So you guys, right? Let's imagine that in the hairdressing or the steel company, they tell you at the end, I want a report that gives me all of the products that have been sold in a month, and this is how the report should look like. This is what I want, and they're giving us this. And from this, we have to obtain the tables, and for the tables to be congruent. So this is not a pet store. This is a veterinarian. This is a veterinarian clinic or something like that. So what do we have? We've got pets. Pets have owners. The pets have certain information. The pets, do you notice that the pets have a sort of like a clinical record? So each pet has registration when the pet came to a consultation and what the consultation was. We've got the pet type. Each pet has a pet ID. Okay. What do we notice? What do you notice there from looking at that information? Things that come up that we should keep in mind. The dates have a format. We could reformat them if we wanted to. Dates have a format. What other stuff? The procedures have the number and the name, and that's a combination of a whole text. That's not atomic. It might be best to have a table where I have the number and the name of the procedure.
We're repeating a month. It's January, then.
No, the name is the month is in the. This is written in the letter.
That's the same order.
Do you notice that an owner can have different pets? So Sam Cook has a dog and a cat, Rover and Morris, and Terry Kim has a dog and a bird, Spot and Tweety. And somehow the pets are identified by an ID. The owner, not necessarily, it's just put there. Okay. Let's see how we can unpack this, like going to the groceries, how we can unpack this to have the information in different tables. So the first thing we're going to do is that we're going to literally grab this report and we're going to put it in a huge table that has all of that information. Okay. So we're going to grab all of this and we're going to put it here. This is the macro table that has all of the information, all the data there. It's not the ideal way to store this data because, again, we've got values that are, we've got values that aren't atomic. we have a combination of different types of entities. We've got pets, we've got owners. And so this isn't the ideal way to store this information, and we wanna see if we can unpack it. Off the top of your heads, what type of tables should we get to in the end? Which ones? But what would be kind of some logical tables or entities that we would have?
Maybe we will have one with the pet ID, the date, and the procedure.
So one is gonna be the pet, okay? Then there's a procedure that, or a consultation that the pet has. We've also got an owner, and we've got the procedures themselves. So those are some ideas of the tables that we might be generating. So the first step is putting all of that into the table, into one large table. Then what we're going to do is that from this table that we have here, if we want to find this specific information for a pet and what the pet went to the clinic for, if we just have the pet ID as a primary key, we can't get that information because 246 is Rover, but Rover has gone 3 times to do 3 different procedures in 3 different dates. So if we want the complete information for a specific consultation or visit for Rover, I need the pet ID, I need the date, and I need the procedure. And so we're going to create a composite key, which is the pet, the visit date, and the procedure. And this is going to give me the complete information for each of the visits or the consultations that the pet had. But we still might have some partial dependencies happening around it. So what we're going to do is that we're going to separate this into a pet table. And so the pet table is going to have the pet ID, the name, the pet type, the age, and owner. All of these are in second normal form because there are no partial dependencies. All of them depend on the pet ID. Then we're going to unpack the procedure into an identifier and a name. Just so that isn't in an atomic, those are atomic values. So there's going to be the different procedures with the procedure name. And then we're going to have the pet visit table or the consultation table that's going to give us the composite key of the pet ID, the visit date, and the procedure. And that's going to give us the information of the specific visit for the pet. So now we've got those 3 tables. In the case of those 3 tables, there aren't any transitive dependencies. So remember, none of the fields or attributes are going to depend on another attribute that isn't the primary key. So in this case, these 3 tables are normalized. Now, if we wanted to, we could add an owner table. And that owner table might have an owner ID or identifier, the name, and maybe their address. And we could put that as an additional table if we wanted. Okay. Once we get to this point where the information is unpacked, we can add other entities or tables that we want and relate them to the normalized tables we've obtained and verify those as well. Okay. Questions with these up to this point? You guys are going to practice, and practice is going to help build this. Are you guys going to be having exams this week? This week and next week? Tomorrow, they start tomorrow? Well, you haven't had exams yet? Any exams? For what course? Done. How are you guys feeling before your exams? Relaxed, cool, nervous? You seem very relaxed. You're a very relaxed group. The other group, the fourth semester group, is really stressed about their exams, but you guys are cool. Exactly, yeah. The exam must fear you. That's good. That's good, that's good. Let's look at another example. This is a Hilltop Animal Hospital. This is actually one of the exercises we're going to be working on in Excel. Access lab practices. The Hilltop Animal Hospital. I actually think that if this is in the United States, I think that it's probably outdated and it's probably. Do any of you have pets that have taken them to stuff in the United States? I think that's probably cheap. Probably right now, vaccines probably going to be better cost. So what do we have there? This is another example of sort of the reverse engineering. Let's say that we've got the Hilltop Animal Hospital, and they want us to create the structure of a database. And what they're giving us is an invoice. This is the invoice that I'm going to give the customer. And here's all the information that the invoice has. I want the database system to be able to create that invoice. So how would the database system or tables need to be structured to be able to create or generate this information? So you have to be careful when we're looking at these sorts of examples. And I think we mentioned this in the first example we talked about. To be able to identify things or data or part of the data that are going to be relevant and others that are not. So I believe that when we were talking about the, I think it was a COVID vaccination example, that in some of the discussions that came up, somebody said, well, the government is an entity, or the United Nations Security or Health, the World Health Organization is an entity. Well, yeah, they are part of it. However, they're not entities that are relevant for the part of the database or the scope that we're talking about. And so, for example, what is information that the invoice has? The invoice has Hilltop Animal Hospital. That's not really relevant because all of the invoices are going to be from the Hilltop Animal Hospital. This is thinking about our database because you're going to design forms. This is probably going to be a fixed header in the invoice, but this doesn't necessarily have to be part of the tables or the structure that we have. There's an invoice number that is important, a date. There's the information of the owner, and then there's the information of the pets and what they have. Notice that this example, let's assume that the previous example was also part of the Hilltop. Animal Hospital. What are we looking at here? The scope that we're looking at here is a report that has to do with what procedures I've done to what animals. What is the view that I'm seeing here? I'm seeing the invoice that I'm giving the customer. It's the same organization, but there's different perspectives. Remember when we were talking about your final projects that I talked about scope in each project? Like, oh, well, we want to, I believe it was in the hairdressing one that said we want to, and the steel one as well. And also in the restaurant. We're talking about, well, we're going to be looking at inventory. Yeah, but we also want information on the customer. Wait a minute, that's another thing. we're talking about inventory, let's just look at inventory. If we want to look at the behavior of the sales of the products, that's what interests us. We're not necessarily worried about the invoicing or the facturación. That's something separate. This is the same example. In the first one, we were looking at a report that had to do with what procedures I did for a pet. That's more similar to the inventory problem because this report, what is the most common, just looking at this, what is the most common procedure that I'm doing? And for what type of animal? Rabies vaccinations for dogs and cats. That's the most common procedure. That's what the report might tell me. That's what might be of interest. What product is being sold more? What menu item is being sold more and what dates, etc. But I'm not interested in the information for the customer. Who is the primary entity here? It's the pet. Because who's getting the rabies vaccination? The pet or the owner? The pet, right? I believe there are some owners that might need rabies vaccinations, but that's another thing. Who is the primary here? What is the primary focus for the invoice? Who's paying for the rabies vaccination? The pet or the owner? The Richard, exactly. Mr. Richard Cook is paying for the rabies vaccination. So the focus here, or in another way, we're not giving the invoice to the pet, we're giving the invoice to the customer. So it's a different view. Okay. Are we clear up to this point? Okay. So the first thing we're going to be doing is that we're going to be unpacking this information. All the information from the invoice, we're going to create a huge table that's called customer invoice table. And the invoice ID is going to be the primary. Obviously, again, this isn't the ideal way to store the information. There's a bunch of partial dependencies there that are obvious. The invoice date is going to depend on the invoice, because the customer address just depends on the customer. The procedure is going to depend on the pet and the invoice. The amount is just going to depend on the procedure. So there's a bunch of, that's actually a transitive dependency. The amount is going to depend on the procedure, and procedure isn't the primary key. So those are the things that we need to navigate or eliminate. So what we're going to be doing now is that we're going to create first a composite key. We're going to have the invoice ID and the pet name as composite primary keys. That way, if I look for the invoice and the pet, I'm going to be able to identify the procedure and when it was done and how much it cost. However, we still have some partial dependencies there. So what we're going to be doing is that we're going to be creating a pet table where we just have the pet ID and the pet name. We're going to have a customer invoice table that's got the invoice date, the customer address, because the invoice, that's a one-to-one relationship. The invoice, there's one invoice, it's going to be directed to one customer. And then the pet invoice table that has the invoice information, the pet ID, and the specific procedure that was done. Oh, by the way, another thing that we have to be mindful of. Notice that we're not storing this information. We're not storing the tax and the amount due. Why? Because those are going to be, the tax is going to be a constant that we're going to be using for a calculation. The total amount due is going to be a calculation that the table isn't going to be doing that calculation. Our database processing, when we generate the invoice, that's the moment where we're going to be doing the calculation. It's not going to be part of the data set.
Separate table to store those results?
That's a good question. So the first question is, in what situation would we need a table to do that? Well, first off, if the tax, let's say the typical when you order something, the California tax, I don't know if you've ordered something in Amazon or whatever, that there's a tax for California. that's pretty high. If the tax is going to be fixed, it's the same, then you really don't need a table for it. However, let's say that the tax is variable. I don't know if this can occur, but maybe the tax is different in different states and according to the type of animal, for example. Or you have discounts for different types of customers. That's a situation where that is data that you might want in a separate table. Okay. What we're not going to need a table for are the calculated values. Calculated values are done in the moment we generate a report.
Oh,
Okay, yeah, the amount due is actually in your databases. When we start doing the programming, you're going to have to do forms and reports. A form is going to be where you input this, and a report, well, rather when you input the information for the tables. A report is going to be saying the invoice. And when you generate the report, there's going to be a field that's going to be a calculation, which is going to be the sum of this multiplied by the tax, and that's going to be the total. But that's going to be created the moment you generate the report. You don't need to store that every time necessarily. And the other thing, lastly, that we're going to generate, we're going to generate a customer table. Just so we keep a record of the customers, because since the customer is the primary focus, again, there might be a situation in the world where we might have two Richard Cooks. And so we want to identify them separately. And so we're going to add a customer table that has a customer ID, just so we can clearly identify our customers. So a customer invoice table, a customer table, a pet table, the procedure table, just have the procedure ID, the name of the cost, and the pet invoice table. And all of these are going to be are normalized or in normal forms, and we can and are ready to be. Okay.